Hi everyone, my name's David Murphy and I'm going to talk to you today about building databases specifically with Terraform and in AWS. And we're going to talk about isolating the databases from applications, security, and fun and usability type stuff that is contrary to a lot of normal architecture. So you understand a bit about myself. So my name's David Murphy. I've done a whole bunch of stuff. I was the global architect for electronic arts for MySQL and NoSQL stuff. I was part of a Mongo database as a service startup that got acquired by Rackspace. I worked for Percona itself as the head of Mongo and everything there. And these days what I do is I work with an airline in Ireland. I'll let you figure out which one. And I focus on all of their database techs, moving it to the cloud, but also thinking about how we move this data to the cloud, and we do it in a secure way where we limit people's access to the data where we should, because as you might know if you've ever gone on a flight recently, there's a lot of your personal data that gets stored tied to your travel tickets. And so that's kind of where my focus is, but a lot of my area is around cybersecurity, where it meets databases and privacy concerns, and then where that meets AWS structuring for those best outcomes. So what we're going to talk about today is when you choose between VPCs and accounts, what cattle and pets are and how we think about those, especially when it comes to databases, network planning, EC2 and RDS type stuff, DNS security groups, and then I'm talking through all of those things so that I can draw you a picture of how it all fits together and why it makes sense. And then I'll talk about some other stuff that we would think about next in the life cycle of stuff, because I am evolving this pattern. But this is a good starting place for a lot of people. So I'm starting with the building blocks, and the first one is these VPCs and accounts. If you don't know what a VPC is, or an account versus a subnet in AWS, the simple thing is a subnet is your smallest unit of work, obviously IP space, subnets. And in that, then you have VPCs that can hold multiple subnets, and then accounts that can hold multiple VPCs. And in this, there's 4 basic schools of thought that a lot of companies go through. And the first one is we have one account, we have a whole bunch of VPCs, or one VPC and a whole bunch of subnets that just everything is in there, and we control everything through security groups. So we treat it very much like a flat data center that we used to have. This has a lot of problems with it long-term and scalability and maintenance, but it's where a lot of people start. Then people start evolving into start using VPCs per environment, where there's a subnet for that, and that VPC environment cannot talk to other things, so you create some isolation there. Then you might actually start getting bigger, where we're like, okay, well, instead of one account, I want an account for finance, I want an account for HR, I want an account for the mailroom, I don't know, a whole bunch of different things. And then finally, you start having to think about this a little bit differently, because, all right, now we have data governance issues. Do we really want some of our GDPR data or the privacy PII type data or PCI data sitting in the finance group and some of it sitting in the data warehouse group's account and having to go find all those databases? And my answer to that is absolutely no, we don't want to deal with that. What we want to do is we want to create database accounts, and we store everything in that account, and we use VPCs to separate those environments. And then I'll talk through and show you how we do some stuff as well, so that we can make these databases appear in the same IP space of the apps for those things, but they're still in these accounts, and we have that central control, and then governance becomes a lot easier for your data team, whether you're a DBRE team, an SRE team, or a DBA team. So that was kind of the basic design of them, and I kind of outlined this. We can go through this more later when the slides go up on Percona's website. But basically, I was breaking down exactly what I was just saying there, where subnets are one account, one VPC, a whole bunch of subnets just trying to control everything. I talk about how it's easy to set up, it's easy to deploy, but you're trading a lot of technical debt that you're it's going to hurt you later. And if you're new to the cloud, you're going to do this. Everybody does this, and everybody regrets that they did it. And then they have a big modernization project that goes on. VPCs is kind of where a lot of people sit outside of that, where they don't run multiple accounts. And I can't stress enough, run multiple accounts. It will make your life better, especially when you start looking at AWS SSO, and you can start saying that this person has access to this level of access to this account, but this lower level of access to this other account, and then you can start hooking it into your Jenkins processes and stuff like that, and it works really well. I did want to talk about the account kind of separation. There is the flavor of business versus operational area. And what I was saying where I want database accounts, that's me breaking it down by operational area for data specifically, and then using business accounts for the other systems. And what I'll do, I'll talk about cattle versus pets in a minute, and I'll explain where that line is and why you can do that line, and it'll make logical sense for everybody. All right. But yeah, one thing I didn't say there on the accounts is one of the designs that I have there is I want one set of rule for auth. And so that's to say, inside of a single account in AWS, you have SessionManager in AWS. I don't know if any of y'all have used it, but SessionManager allows me to get onto a machine without actually using SSH, which is amazing. I can meet a lot of zero trust security concerns there. But if I set it up to where I integrate my SSO to use the LAN ID that's powered by Active Directory in my company, I either have to turn that setting on or off at the account level. So if I want my databases to be protected through that and use Active Directory memberships to decide whether or not you could sudo to the Oracle or the Mongo or the MySQL user to have super privileges to the database data files, I can do that, but then have I set up everybody else in the SRE or infrastructure groups to have that LAN ID and have that for their sudo as well for disk management type stuff? Probably not. And so that can create a problem, and so I'll talk about that in a minute. And so that's when we get into cattle and pets. A lot of people have probably talked about this, and you're blue in the face from hearing it, but cattle and pets, it really comes down to a pet is, and there's big text here, I'm going to summarize it. A pet is a system that, for all intents and purposes, is stateful for some reason. Whether it's a Windows server that it's really hard to rebuild, so you don't want to throw it away and just build another one like you might do with a LAMP stack machine, or it might be a database where, again, destroying it and rebuilding it is a lot more effort. Not to say that I don't want to get there with databases, it's just a much more complicated process to build rebuildable databases than it would be an Apache server. Cattle, on the other hand, is that typical Apache server where if anything goes wrong with one of these web servers, just throw it in the bin and let AWS build another one, and it'll just fix your performance issues. Or you're running hot on those servers, and so AWS just builds you 5 more, and now your load balancer is able to balance that, and the machines are not hot anymore. In both cases, what I like to do is I like to make sure that we're using Ansible, we're using Chef, whatever your tool of choice is, to actually configure the database OS. So what I do in my practice at the airline is I'll use Oracle as a good example here. Because of the tags and stuff that we'll talk about that Terraform puts in place, the Ansible can come in and it can figure out the host name, the environment name, a whole bunch of information, including what template file to use to set up the database data file locations and sizes and stuff like that. All of that can be done through Ansible, driven from this Terraform code that we're going to talk about. And that's the real secret sauce I have there, is everything that I've done with the Terraform that I've done made it to where I'm just updating like 6 lines of code, and I've created a new environment, but it's programmatically set what the host name should be, what the service name for the database should be, all these other things. It's set where secrets are being stored and all this kind of stuff. So we've created isolation, we've made it an easy way for the team to find it, but at the same time, your DBRE team can say, hey, we have template XXX now. Well, XXX, we need a new copy of it that's called YYY. And in that, all you have to do is copy that template file and change that one line when you're building a new environment, and you're done. You don't have to touch any more of this Terraform code to implement that. And that's our goal here. And that's why I was talking about it here is in the same way that I want that for a cattle type system, I want the consistent building of a database at a base level to be done through Ansible, and then have Ansible be able to pick up scripts from a folder. For example, in my scripts folder I have something called a sid.d folder, and if my sid was called YYY, then any SQL files it finds in that folder, it would run those in lexical order automatically for you at the end of the build process. So what you end up with is a system that knows how to build itself, and you don't have to touch a lot of stuff to expand into new areas. But in this, I talked about earlier how you probably want separate accounts for security purposes, but you also probably want separate accounts for reporting purposes, figuring out who should have access to it, what encryption keys you might use, because you probably don't want to use the same disk level encryption key for each database tech. You probably want to use different ones, in the same way that you probably want to use different keys for your Java servers versus your MySQL servers, so that if an encryption key became vulnerable or compromised, you would limit the scope of what servers had to be rebuilt in your stack. And so all of these things are what I think about. Now, one thing that you might not have run into, depending on where you are with AMIs and Terraform and stuff like that, I tried to build an AMI that had Oracle installed. It got to the right version. It set up the disks. It did everything. And all I had to do on the final step of it is it read a couple of your tags and then changed the DB name of the Oracle machine. Postgres has some similar stuff. MySQL has some similar stuff you could do there. It sounded great in principle, but what I learned, and I don't want y'all to have to learn this as well, is AMIs, if you bundle extra disks into them, Terraform will not be able to manage that disk size. Terraform will try to destroy that disk when you try to increase its size. So don't do that. And it all comes down to Terraform didn't create that disk, the AMI created the disk, so Terraform doesn't know about that disk. And so what I've done now instead is I build a very thin AMI, and I let Oracle, Mongo, MySQL install itself on top of that as part of the first boot process. And by doing that way, I never run into that same disk problem again. But it means that instead of it taking 10 minutes to have an Oracle server available, it now takes me about 2 hours, because that's how long the Oracle install process takes. Obviously, MySQL and Mongo are much faster at this, but it's still the same problem. Be aware of that with AMIs. So networking, this is a much more complicated area. I've talked about subnets, and there's routing stuff, there's VPC peering, which is letting two VPCs talk to each other because app A needs to talk to app B or something like that. And then there's PrivateLink, and there's RDS issues with PrivateLink. So let's talk about that for a second. So in my accounts, I have purposely made every single database environment use the exact same subnet and reuse IPs. And I did this, and it sounds very counterintuitive, but I did it so that if anybody ever got in the system and changed the routing table to try to get to the databases from an application system, it wouldn't work. Because even if they were able to set up that VPC peering, it's not going to know how to send it to those things because there's overlapping subnets. And so I did that on purpose as an extra layer of defense. You don't have to do that. And I'll show you in the code where I chose to do it, but it's a single variable change that you would change to make it do something else. All right, so that's kind of your routing considerations and stuff like that. VPC peering, I am not a fan of VPC peering in AWS, and here's why. VPC peering means that I have to have some central governance of who is doling out IPs and what ranges are being doled out to what accounts and what VPCs, that is actually problematic. You have to buy some sort of stack or software to do IP management. It's also much better to say, okay, let's not do VPC peering. Let's talk about PrivateLink or VPC endpoints. If you've never worked with those, what those are is you have, let's say you have an EC2 instance and it's on 1.1.1.1. And you put a load balancer in front of that. Only points to that one machine. That load balancer can be set up as what's called a VPC endpoint service. And so in this account, in this VPC, I have an endpoint service. I can make another VPC in the same account, or I can use IAM rules to allow other accounts in their VPCs to attach to this endpoint service and create an endpoint. So in some FAR account, let's say the IP address is 10.10.10.12 of the endpoint that gets created. And the app server is 10.10.10.10. 10.10.10 connects to 12 in its local subnet. AWS routes that over this VPC endpoint to the endpoint service, to the load balancer, to the database host. There is not a direct connectivity in the system. It's all flowing through this area. The load balancer and other things have different security groups you can put in place. But without creating this endpoint service, and this gets into the isolation that this talk was talking about, there is no way to get to the database service until you create the database server until you've created that endpoint service or you've used AWS SessionManager. And so you've kind of created an air gap system in a cloud so that you are maintaining some rules that you might have in your company on data security as you're trying to move to AWS. But also with PrivateLink like this, it lets me do some really interesting things around being able to quickly give 15 accounts access to one database and use Terraform state file to actually import that. And I'll show you how that works here in a bit. And it's like a one-liner. It becomes very, very nice to manage this stuff. RDS issues with PrivateLink. I think this is an important one. I am currently writing a module that I'm hoping to make public and open source to solve this problem. But the problem is this. VPC endpoints are designed to use EC2 instances because they use a load balancer, and load balancers either need an EC2 instance as a target or they need an IP address as a target. Then you look at the other side of the equation. RDS is built to where I think the smallest subnet you can put in an RDS is a slash, I can't remember if it's slash 25 or slash 28. But it's relatively large IP set for something that would only have 2 or 3 IP addresses if you had multi-AZ turned on. And so you can't really put all of those IP addresses in a load balancer and tell it to load balance that. It won't work that way. So instead, what I do is I actually create a Lambda that attaches to the RDS on a change event. That Lambda is fired. It goes and looks at the IP addresses that are currently in the load balancer and looks at what the RDS IP address is now. Is it the same thing? Does nothing. Is it not the same thing? It updates that. And so we've created an automated system of fixing any HA so that endpoints will work. Without doing this, you would be putting IP addresses into your load balancer's target group manually. And if there was ever a change, then at 2 a.m., somebody has to wake up, go into the AWS account, and update that load balancer. So that module is coming soon, and that will be helpful. I was just talking about that. It's all because they're not compute. This is what this slide here is kind of. I forgot I created a slide specifically on that. But this is all the pain points for it. You can look at it. But it's not just limited to endpoints, because some of the same logic you might use for proxy SQL configuration and stuff like that, you might want to use some of those same lambdas so that you can trigger whatever your proxy layer is, whatever your read-write separation layer is, these types of things to happen. Now, I will say I'm friends with Renee, who writes proxy SQL. I like proxy SQL as a product. I don't like that Proxy SQL doesn't cover all the databases I have to support. I wish I had a SQL proxy that went across the spectrum of stuff that I ran, because then I could use that as a central system. And so we don't use Proxy SQL where we're at, because that would only benefit one small section of our landscape. So this kind of talks about the load balancer update that I was just talking about, where at number 1, you're just in a normal running state. But then an RDS reboot occurs. Let's say it did a maintenance window, decided to patch it. When it came back up, it may or may not have the same IP address. There could be a hardware failure in Amazon, and they pivot you to another hypervisor. Again, your IP address could change as a result of that. This Lambda would fire in those cases and update stuff automatically. So then we get into DNS. So this is where I spent a lot of time thinking and designing what I wanted to do with DNS. Because when we start talking about endpoint services, the question is, if my database is, did I use an example database in the slide? I didn't. If my database is db1.az.mycompany.databaseprod, whatever. In my local account where the database is, that might be like a 172 address that's not routable to anything else. But when I go to publish an endpoint service, and then an endpoint in the app account somewhere else, the endpoint has a natural DNS name that Amazon gives it that is like VPCE- some ID number. Terrible for reading in a configuration file. What I do is when I publish an endpoint service, I publish a tag on it called FQDN, which is the name of the actual database instance in Terraform that we used, so that then when I create that endpoint, we register a local private zone in my remote account, and that has the same name, so that whether I'm a DBA connecting to this instance, I'm a dev person connecting from my desktop through the DMZ zone to this instance, or whether it's an app connecting to this instance, they all use the same name, but DNS is aware of sending them to the right endpoint for where you're coming from. I really like this pattern because it makes the number of mistakes that I see the infrastructure and the development teams hit, because they're like, the database doesn't work, and you're like, well, you're pointing to a subnet that doesn't exist in that type of account. This gets rid of all of that, and I would say that the largest support problem that we had in AWS after we did our Terraform stuff was exactly that until I put this DNS in place. It was people copying and pasting configs and getting confused when things didn't just work. That said, the public-private zoning does cost money, so look at how you do it. I was very selective in what I did and when I did it to try to limit that. And what I did is I have a database name that is database shared services.tld. I have database.company.tld, and I have database-nonprod.company.tld. In that one, I will create a record that is like foo.blah.bar.blah, a really long record. Instead of creating separate zones for every subdomain, create one zone so that you only pay that tax in AWS once, and then manage all of those records directly in there. It sounds terrible if you were managing the DNS yourself, but since you're using Terraform to do it, there's no reason not to do it that way. So that was one point. I've kind of talked through these. That said, when it comes to load balancer design with endpoints, I have played with two patterns, and so I think this will be helpful to everybody here. The first pattern is where I took a Mongo system and I had a replica set. So 27017 was node A, 27 in AZA. 18 was the AZB, 19 was AZC. And I put all of those in the load balancer as separate ports on a load balancer, so I didn't have to create 3 different load balancers. I have since decided that that was a mistake. I have found that it adds more confusion to people, because then when we pivot over to something like Oracle, where we decided that we're always running Oracle on port 1521, I can't do that same pattern. And so if I have a primary and a standby in Oracle, I need 2 different load balancers. And so because I did Mongo first, I thought I would get away with the multiple port thing. So definitely when you're doing some of this designing and this isolation planning for yourself, think about some of those, what all technologies am I going to support? Am I going to be allowed to use different ports, or is the development team only going to use the default port for the database tech? If they're only going to use the database default port for the database tech, then use one load balancer to one machine, and that'll keep your life simple. It doesn't really cost you anything different on those load balancers. It's a couple cents. But the bandwidth is the same bandwidth whether you have 3 ports on one load balancer or 3 load balancers. Okay, so the DNS, hopefully this gives you a better idea of what I've been talking about with the DNS, where inside of my shared services account and my prod account, I have 2 different zones, the myOrg, but both are with the domain of myOrg.tld. And then in each subnet, I have these endpoints set up, and you can see that by kind of the octagon. That is a VPC endpoint that those things are pointing to. But then when you get into the database prod account, you can see that the app server, the DNS for the app server is pointing directly to that app server, and that's an alias, that's fine. And then the database points to an EIP that points to, for public, points to an EIP that points to the VPC address. Or for private, it just internally points to that VPCE. And that way, in each one of these locations, it can look up a different record for the VPC to know how to get to which endpoint it needed to get to. Because an endpoint cannot cross a VPC boundary. So it's not like in the left side of this diagram, the VPCE for one VPC could be used in another one. I need separate ones, which means I need separate DNS of some sort. Okay, so password and security management in AWS. This is a challenge because there's a lot of people that store passwords in Git still. And if you're using Terraform, you're probably putting your Terraform into Git. Don't do that. Please don't do that. Please use like Secrets Manager or Parameter Store. If you don't know the difference between those, Parameter Store, if you're not going to do auto rotation of passwords, which is, I would say, is a V2 of infrastructure design, then go to the Parameter Store. It's cheaper. It's practically free in almost every case. Because I think you can get, it's like 50,000 parameters that you can store per account before they start charging you money. So it's ridiculously effective. But make sure that you're creating IAM rules. Make sure that you're limiting the scope of access to these secrets and keys that these secrets are assigned to. When I create a secret for Mongo, it is keyed to the Mongo key, and then the Mongo instances are given IAM privileges to read that KMS key, and Oracle instances are given access to the Oracle KMS key. So no Oracle server, even if somebody opened up the privileges to say read all secrets, would be able to actually read that Mongo secret. And so you couldn't have that it's not exfiltration of data, but that leaking of data across those areas. If you want to get really serious about your security and your isolation, use X509 certificates and do certificate-based authentication on all your stuff. It's a giant pain in the butt. I'm not doing that right now because the amount of development team effort that would be required is not inconsequential. But then the last thing on this slide that I wanted to say is I am working towards the point that all database passwords for whatever template is being called are going to be put into the secrets automatically by Terraform. It'll get built, but then I'll create a Jenkins job that will allow a user to click a button, and that'll be able to log into the database, unlock a user, reset a grant, and automatically change the password, updating that secret. And then that way you can then go, okay, well, I've updated this password. Now I updated the password for my payment system. Payment system applications, go restart yourselves. Go do a rolling restart, and your connectivity will come back. That's kind of the goal that we're trying to go with. The other thing is I created a rule inside of our organization that says all databases shall use Active Directory LDAP authentication for interactive users. So that's to say, if I am developer A, I'm using the credentials I would log into my email with to get to a database in dev. If I am a DBA, I'm using my credentials to get into any of the databases. If I'm a business analyst, I could try to use my credentials, but it just won't give me any rights in the database because I'm a business analyst. I haven't justified my need for access. And that lets me do least privilege, but also making it to where people aren't forgetting what their passwords are and you're just resetting passwords all the time. Or worse, we're making it to where developer teams know what the passwords in prod are. Those teams don't know what that password is, so they can't be logging in as that password behind the scenes. But there's a lot of work that gets into aligning with development teams so they understand why you're wanting to stop their shared access of passwords. Okay, security group planning. Yeah, I like to use small subnets for each VPC and then put stuff in there. One thing I will say about security groups, when you're using VPC endpoints and these load balancers I talked about, the incoming connection request that the load balancer is going to see, I should say that the database instance is going to see is the load balancer's IP address, not the originating IP address of the app server. There's things that you have to do with load balancers in AWS to expose that type of port, just like with any other load balancer technology. But this is important for security groups because you probably are just going to say, when you're setting up your load balancer, allow my load balancer, whatever CIDR the subnet is, allow that whole CIDR to connect on my database port. Then what you're doing is you're creating a control mechanism in Terraform where you're specifying the allowed principals or allowed accounts that are able to talk to that endpoint service. And then in the application account, you're creating yet another security group rule that says allow app server A to get to endpoint A and nowhere else. And so you can create all those same security things, but at different levels. By doing this and creating the CIDR level security groups, you're not going to run out of security group rule entries. And so you're going to keep yourself from running into some very problematic things, which is I've run into in our setup where I have machines that have the maximum number of security groups attached to them, and every single one of those security groups does not have space to create a new rule on their chain. And so then I have to start figuring out how I squash certain rules together because I need to fix production. We're getting away from that. We're doing this new design. Okay, so I mentioned SessionManager before. I just quickly wanted to talk about it here again, which is I don't think you should ever use the AWS Serial Console feature in AWS for your users to access a machine. There's a couple reasons why. The first one is if somebody types a command in that Serial Console and it starts catting a 1 gigabyte text file, you are never going to get access to that console again. Because it is just going to get jammed up and it's not going to work. SessionManager I like a lot more. Bastions, I am actively trying to get rid of all Bastions in the system and use SessionManager, because with SessionManager I can use AWS SSO, I can use multi-factor authentication, I can really start putting in some strict controls. And what I do with SessionManager is I do SessionManager plus SSH. So my DBRE team, they will go to their local machine. I'll set up their SSH config file in such a way that they would say, SSH host name of the machine, it will automatically fire SessionManager, which will open up a SSH session type in SessionManager, give that back to the SSH client, ask them what their LAN ID is, ask them what their LAN password is, and then log them in as their user on that system. And now we've done PCI level, nobody is going into a shared account and then becoming another user. They're going into their named account. We can trace who did it. SessionManager has all these logs in an immutable state. It's great. It meets a lot of those security concerns. Okay, so I'm running a little low on time. So this gets us into actually how an account looks and is set up. So if you look in database non-prod, you'll see kind of there's this blue, well, it's green on this screen. I don't know why. It's blue on my screen. A little scroll type icon. And that's your VPC endpoint services that are defined in accounts. And then that hexagon kind of thing, again, is the endpoints that you would see. And you can see how there are endpoints connecting these different things, but they are virtual lines that only connect those specific things at that specific time, and they are not full subnet routing type connectivity. And so you are creating pinpoint connections rather than broad connections through these database accounts. Then if you see in the shared services account at the top, what I have is I actually have like an Oracle subnet, a Mongo subnet, a MySQL one, an MS SQL one, and I would put tools that each of those technologies use there. So OEM, PMM, stuff like that. So that's the basic architecture view. And so when we're putting this together, we're going to get into some code now, but all you would need to do to create a new environment in this type of code is you copy one environment folder to another one, you change the inf.yaml, maybe the terragrunt.hcl, we'll talk about that here in a second, and then the module itself is going to handle EC2 instances, creating EBS volumes and tags and load balancer and endpoint service. All of that happens automatically in the code that we do. And then passwords and all of that, setting up monitoring, all of that happens in a really natural way. And so this, for example, is the multi-line file that I was talking about, where this first name field that's in inf.yaml, if you're familiar with Terraform inf.yaml or Atlantis, inf.yaml is a pretty common name for the settings that you intend people to change. And name here, that performs the base part of the name of a machine. It performs the name of the VPC, the name that you would put on subnets, part of the name that makes up secrets, the part of the name that makes up endpoint service names. And so it really connects everything together. Application, Oracle SID, Oracle version, database instance count, Apex version, all of that stuff, I think those are pretty self-explanatory. If you wanted to build a new environment and you wanted it to be on 19.15 instead of 19.14 Oracle, literally copy this folder, change that one value in it, and change the name, and you'd be done. That would be a duplication of that environment, and then you could go test the new version and decide whether or not that patch worked for you. I talked about the CIDRs earlier. You see at the bottom where I have 172.39.00.16. This is controls like setting up the VPC, and if I was to change that to any other number, doesn't matter what it is, it would build everything using that, and it would not have any conflicts. It would, because it just expects that you give it a /16, and if you've given the VPC a /16, it'll automatically carve that up into 3 availability zones and set up all the subnets for you. The code does all that, and we're working at Amok to make a lot more of that code public soon. But like as I say on the slide here, you can see that we create environment names that are tech-name. So for example, in this case, you don't necessarily need to know what MIS is, but you can tell from here that we're talking about an environment that is for Oracle. It's an Oracle database for the MIS application in the test environment. And that makes up part of your DNS name as well. That's the subdomain of the DNS name because it's also the environment name. And so then if you're looking at a config, you can easily know Why are you trying to connect from dev to test? Why are you trying to connect from prod to stage? Stuff like that. The next file, and sorry, on the left side, bottom of the screen, there's a DMS folder, an environment folder, a monitoring folder, Oracle DB folder, and a VPC one. Terraform, when it runs, is going to go into each of these, and it's going to run them. And we're going to look at one of those files now to help you understand what's happening there. Now, it's a little small, and so that's why I kind of broke up on the side where the text is to kind of explain some of this. But line 2 of this file says source equals, and it's a get link to where we keep our modules. And I do this because at the end of that, I can put a version there. And so now Terraform can actually version lock what we're doing. And when I go to upgrade an environment, I could bump that version to get it to do something new, like expose new endpoints or whatnot, without having to change anything else. But if further down towards the bottom of the file, there's a section called inputs. And the inputs is all the incoming variables. And so you have things like app disks, you have things like are we going to have Oracle Apex servers? Are we going to have, I don't know, PHP MyAdmin? Are we going to have, different things like that you might set up in your shared services account? Are we going to create DMZ access? And by DMZ access, what I mean is, am I going to make an endpoint automatically appear in another account that handles when people are connected to the VPN of my company, that I want them to be able to get to this database from their desktop through some sort of SQL development GUI tool? Or do I want to turn that off by setting that Boolean to false because I only want the applications connecting into this database? So that's kind of the stuff that we were doing there. Again, don't forget the disk problem on AMIs that I was talking about, because down in all of this code, there's a section where you could actually specify the version number of the AMI as well, so you get maximum ability to control and use this stuff. And this is all the usability thing, is you need to change almost nothing in this file to make something work. But in inf.yaml, you could add app1_disk, or in this Terraform file, you could change the disk value there. And either one would have an outcome of giving you the bigger disk that you needed in your environment. And in fact, you could do that once a machine's built. Because it's Terraform, it's just going to increase in place that EBS volume, and then you'll have to obviously go tell your database how you want to use it.
Those files, it will override the AMI?
Oh, well, so the AMI doesn't set the size of the disks. In our setup, the Terraform creates the disks and attaches them to the instance. The AMI is just creating the base OS for you. And then Ansible is doing all the configuration on top of it. And so like if I had set up a database machine and I go into this file and I change my app disks from 40 to 80 because I'm going to do a major version upgrade in place, then what's going to happen is when Terraform runs, it's going to go to the EBS service. It's going to increase that disk to 80 gigs. But then whether you have it in your Ansible code or you have somebody go do it, somebody needs to go run growfs to tell the file system to start using those extra 40 gigs of blocks that are available from the disk. Make sense? All right, and then, yeah, so this is where I kind of helped summarize and show you a little bit more of that input section. And I was talking earlier about inheritance and endpoint services and stuff like that. You can see here about the middle of the section, there's a line that says Oracle DB endpoint services. And what it says is dependency.oracledb.outputs.endpoint services. So in this specific file, you can see at the top of my screen in green, it says monitoring. So I'm in the monitoring folder, and it's reaching into the Oracle DB folder, getting how it set up the Oracle instances, and returning those endpoint services, so monitoring knows how to set up the endpoints that it needs. And you can do this with separate app accounts and all this other type of stuff with Terraform. And so this also gets into that usability, because it allows you to do, instead of hard coding values into your Terraform stuff, you can start having one Terraform state file get information about another one. If you've been in other talks on Terraform, you will see that there is data lookups and stuff like that. Data lookups are inferior to this type of dependency chaining. And the reason for that is data lookups are true at the point that something is run, whereas these outputs are true at the point that Terraform ran last. So if something changed outside of Terraform, you want Terraform to detect that when you do a Terraform plan. Data lookup won't necessarily let you see that in the same way. So that's that one. Modules, if you've not looked at a Terraform module, there's on the right-hand side, there's some examples of modules that I've built. But on the left side, you can kind of see how one's laid out. And what I wanted to talk about to y'all on this, and this is all about management of your Terraform code, is you can see that I have a data.tf. That is those data lookups I was talking about. I have a main.tf. In main.tf, I really only want local variables defined there. And then I want to create different files for, am I doing something with Oracle? Am I doing something with a provider? Am I doing something with an endpoint? And the reason I want to do this is if somebody needs to go edit this module, they can clearly know where they need to go edit, and our PR is going to be very constrained to what that is. And we're not going to have a, oh God, what did you do? Because you moved some files around in one big file, and now you're trying to figure out what was moved versus what was changed, which is always a pain. But also you can see how there's the ability to do submodules. And I wanted to point this one out to everybody here because when you're creating database instances in modules like this, you might have an AuraDB module, but inside of it, you probably want to create a DB instance submodule or Oracle or Mongo or MySQL. And the reason you want to do that is so that I can say instance count 3, and it will just call that submodule 3 times to do the thing that I need, rather than me having to have 3 different AuraDB or MySQL DB folders. It makes it a much more efficient way to where if you saw back here, I had that AuraDB instance count. By using that, I'm leveraging that submodule feature. Let's see. That covered that stuff. So yeah, like here, when the slides go up, you can see some examples of different code that we did and how we did it to do like data lookups and stuff, because I do data lookups. I do them to find very specific things, like what is the zone ID of my public Route 53 zone that I need to add a record to? What is the private zone in this account or that account? And then in Oracle, I have more examples here that show you how I set up load balancers. And I have examples that how the DNS and the parameter store is in. So until I get all this code public in GitHub, these slides kind of show you what that pattern looks like. And you could literally lift exactly what the language is here, and it will just work in your Terraform, because I'm just using AWS or Cloud Posse type modules. In my monitoring, I'm almost out of time, but in my monitoring, what I do here is I'm doing some interesting stuff that you can look into, but what happens is the Apex system creates an endpoint in the shared services so that the Apex web server can talk to each of the databases and have applications show up. If you're in MySQL land, it's probably a PHP MySQL or some other tool. It might even be Proxy SQL and things like that. You would probably put into the same kind of layer. And so this is just a good way to show you how that all works. And then the last kind of stuff that I wanted to say that I haven't gone into yet in this talk because they're part of V2, and that is backups and testing and patching and schema as code kind of things. What I would say here is for backups of databases in these types of accounts and this type of setup, you should probably use EFS and not S3. And the reason why I say that is EFS is more natural to be able to use tools for doing restores and stuff directly from it. But also because EFS can fit into your larger AWS backup strategy. So if you have a strategy that says, I want to take EC2 snapshots and I want to back them up, you can hook your EFS into that same strategy, and it can go to Iron Mountain and things like that. And so I would say that about EFS stuff. Backup testing, The whole point of this stuff is so that you could have a Jenkins job that would create a folder, could test one of your backups, verify that it was able to restore it correctly and query the data, and then throw it away. And we've used these modules so we're able to do that type of stuff. And what I'm doing with that in V2 for my stuff is I'm going to have a new input variable that's going to be restore from backup, yes or no. And then it's going to be backup source. And the backup source could be a local EFS to this environment, or it could be a remote one because, I don't know, I'm trying to restore prod into staging because I'm trying to reproduce a production bug in the staging environment. But I don't want to break the staging database. I want to create an extra one. And then patching, that's a whole talk on itself on how you want to deal with Ansible and Terraform and patching. And schema as code, we can do a lot of stuff with what I talked about here on building the infrastructure, but Ansible and schema as code kind of stuff is where it really has to kick off on how are we getting to a point that we have a usable system with loaded data in it from the point of one of these environment builds. I do a lot of stuff in Ansible to try to work around this problem, but I really want to get to the point that I go into full schema as code over time. But what I would say here is don't try to take on all automations or all Terraform stuff at once. Try to kind of go in some of these phases because it'll make it easier. The endpoint stuff and the DNS stuff is just the most critical thing to figure out up front because changing it is going to be very painful for you later. All right, and so I'm out of time now, but that's my contact information as well, but I'm free to answer any questions that y'all might have as well.